on our agenda is our Internet of Things webinar. This webinar has been organised by AT Virtual Partner Cork BIC. As the name suggests, they too are located here in Cork. There will be 3 panellists and they will be discussing practical IoT success stories, and I will now give the floor to Michael O'Connor from Cork BIC, who will be chairing the webinar. Michael, over to you.
Thank you, Maria. Thank you, Roberto. Good morning to everybody. My name is Michael O'Connor and I'm going to, for the next 45 minutes, chair a webinar with 3 companies who are in the emerging space in IoT, Internet of Things. They're scaling, they have customers, and so can I ask Joe, Dennis, and Mike to come online? Great, and unmute Joe. Fantastic. So if I could introduce my 3 panelists, Dennis Murphy from Oversea, and Joe Parrott from Remote Signals, and Mike McCormack from Answer is IQ. So to kick off, maybe we'll start with Joe. Just explain where you are and what you're doing in the IoT space, and just to say in this that some of the routes to market, some of the ways in which Internet of Things and solutions are handled are applicable across sectors. So this is to give some ideas of innovation as to what scales, what is practical, and where solutions can be driven. So over to you, Joe.
Thanks, Michael. I suppose Remote Signals, we're an IoT company building our own hardware and software, and primarily we use low-powered wide area networks, so Sigfox and narrowband IoT for the most part. We focus on end-to-end applications, and our most successful use cases to date have been in the refrigeration and the commercial refrigeration space, where we embed our technology in commercial freezers that go into grocery stores that we probably walk into daily. The technology that is embedded in those freezers determines the contents that are inside those freezers, and we adjust temperatures of the cabinets based on the food type that's inside there. So it's getting the optimal temperature for storage rather than just the same temperature for everything. And I suppose this allows us to deliver smart energy management to each grocery store, and this is delivering financial savings for our customers. Thank you.
Okay, thank you. And so during this session, we're going to have a few questions at the end. So if you have any specific questions as we go through, if you could use the Q&A function at the bottom of the screen, we'll pick up on that and then have a couple of questions at the end. So maybe Dennis, you could take the next question. What does Oversea do, and where is its role in the IoT space?
Yeah, thanks, Michael, and thanks everybody for having me this morning. I suppose in Oversea, we connect frontline workers to senior executives. We empower the workforce with technology necessary to drive down costs and ensure compliance with industry regulations. We work in high footfall venues from ports, shopping centres, train stations, stadiums, airports. In these areas, we help customers reduce their risk and support their claims defensibility. We allow them to have transparent compliance monitoring of risk-reduced tasks from anywhere. Our system is cloud-based, so all our customers from anywhere in the world can log in and look at what's been done real-time on their sites. Oversea is to be known in the industry as the answer to the visualization employee operational live tool. Oversea, the Internet of Things platform, provides business with the ability to gather real-time data on critical environments and operational data. Our system is driven by mobile device using LoRa sensors, using Bluetooth beacons and NFC, and giving real-time data back to customers when most needed. So that's me.
Thank you, Dennis. And our last speaker, Mike from Answer is IQ. Give us some background of Answer is IQ.
Yeah, thanks, Michael. Answer is IQ is a data analytics company for electricity distribution network operators, right? Which is a lot different in terms of the general discussion here, but is very similar in terms of how we use data. Okay, so just to give a description of the operator itself. So there's an urgent need for distribution operators in electricity networks to improve their reliability and efficiency, and this is costing them money. And if they fail to improve efficiency and reliability, they get hit with penalties and weaker rate cases, right? So in addition to the advent of distributed generation and EV charging, this is adding to the complexity of the network. So that is why, for want of a better term that's now outdated, the networks need to become smarter. We utilize the data that comes back in from the network, which is both operational, which is current on the line, temperatures on the conductor, and we use that in conjunction with static data or indirect data to create models for dynamic line rating, for example, which allows the operator to run the network much closer to its capacity than it has already been done. So that's essentially what we do, and we work in very close connection to the utility operator. And as I say, both operational data as well as indirect and static data, right, to provide these new solutions, right? So it's all about enhancing the performance of the distribution and transmission network. And just to put a context to that, in terms of overall networks, as in overhead wires, for example, there are 25 million kilometers of overhead networks globally that are effectively unmonitored and not intelligent, right? So that's the space where we live.
Okay, so thanks, guys. So let's dig in a little into the architecture. So an IoT, a network built around the IoT space, has got sensors, it's got data being collected, it's got a telematics network to bring it somewhere, it's got security, it's got privacy issues, and speed is actually critical for response time and everything else. And quite a lot of the areas you're working in are mission critical. So if something goes wrong, the network doesn't work, then there is a high cost impact or even a much more serious impact in what's going on. So in the context of that, kind of give us a flavor of the mission critical nature of your network, Joe, and we'll go through this one by one, and of the customer's network and how it works, and where the value is created and why customers come back and buy again.
Yeah, well, I think on our side, yeah, the mission critical, obviously, look, the network being reliable is huge. I mean, for us, the data, and a lot of this is being analyzed in the cloud. So once we have to get the data there, unless if we don't get it into the cloud, we can't actually talk to the fridges and freezers that we want to every day, that ultimately earns us the money that we need on the savings that we're creating for them. So there's two big areas. That's obviously on the benefit side. We have to be very careful of making sure that we've got the uptime. And I think low powered wide area networks gives that to us, because we're not, I think the concerns, especially in retail, especially when there's payment systems and everything going on in the store, that we're not on the same network as those guys. So that's one area of it. And also you end up in times as well when I suppose stores use power in different times as well. And with the products that are actually within the freezers, we have to be ready as well. So we use all our sensors are battery powered. You have battery backup within those freezers, even though they're powered by the electricity as well when they're on. But for us, then on the other way, when we're talking back from the cloud down to the freezer, I think the biggest thing for us on a security element is that we're not able to, that we have the encryption levels and we have the security levels there, that someone couldn't hack us and actually start putting everyone's freezer or, to the wrong type of temperature and losing products as well. So these were things maybe when we started this we didn't think about, but very quickly you start learning from your clients what's important to them and the worries they may have. And this is an area that's interesting. But to us, yeah, look, the network, the openness of it, and then also it benefits both sides. It benefits us on a financial and giving the benefits to our client, but also we have to have that network as well, just to make sure the security is there. Okay.
Yeah, perfect. So health and safety, and that could also apply in the medical area and transporting medical items around at certain fixed temperatures that need to be controlled. So really, really interesting. So moving to Dennis, in your case, in the networks that you supply, some of them are, some of the locations are remote. So you need to provide power somehow and capture the data. Sometimes it's a person. Just describe the environment and in particular how it might work, say, in a maritime situation where obviously safety, security, remoteness is core conditions are also important.
Yeah, thanks, Michael. So yeah, we do work in a lot of remote areas, and we partner with telcos as well. That allows us to get the stable networks that we require. If you look at the picture behind me, it's a maritime port. Based on those environments, we work with teams on the ground from security, cleaning, maintenance, health and safety. And by placing sensors in key areas across the port, we deliver the data back to the users real time. So whether it's a compliance check on a PIV, whether it's a security gate being left wide open at a port, which we all know is critical, we send that data back to the security staff real time using the networks. But using the LoRa, it's much similar to what Joe was saying, using the network LoRa, the LoRa network to send that data back. And it's the packets of data that's critical. It's real-time data at real time for the staff on the ground to work with those. We're in an environment at the moment where every business is conscious of overheads. And I suppose having the staff on the ground that's critical to do what they see at the time is pointing them to the right place at the right time. So we've got sensors that's mapped out around doing simple things like mouse traps, where you got maintenance guys going around, and instead of checking every single mouse trap on a port, we actually send that data back of when there's something caught on a mouse trap using the LoRa network and using LoRa sensors. So it's delivering that data real time back is the critical. Again, much the same as Joe mentioned, our system is end-to-end, it's encrypted. It's hosted by AWS, which is a secure environment. So again, working with these telcos, you have to have a secure network, and we're regularly pen tested again to ensure that we meet those strict requirements from those companies.
Fantastic. And so all of this is linked to network operations centers or security operations centers, and then the customer and the configuration is at the other end. So by collecting data, different parts of the world,
Yeah,
sensors or devices attached to high power electrical cables, could be in the transmission circuit or in the distribution circuit of mainstream electrical distribution and producing systems. So how does it work for you in collecting that data and the sensors, and where do you bring it to? Obviously, it goes to a data center of some description.
yeah, it's an interesting one because in terms of scale, it's not as broad as the two previous gentlemen, because you're looking at devices that are fitted on a power line. There are some advantages actually from a security point of view. For example, when you have a sensor on a 110 kV power line, it's not really at threat, right, from somebody taking it, right? So it's naturally protected. But it also has a number of additional features, which are, for example, that the magnetic fields generated by the current flowing in the line can provide energy harvesting, right, for sensors, so that they actually become, self-powered. Okay, and they communicate then generally by a small wireless link to a gateway device, and then backhaul by multiple. You have to have multiple forms of backhaul communications. GPRS or private APNs and things like that are generally used. They come to a variable number of different aggregators or central points. A lot of utility companies insist on having their own servers, right? So that you point directly to the server as opposed to a cloud solution. And of course, the data has to be encrypted from the sensor all the way through to the server. So it is more bespoke, I think, as a solution. It depends, by voltage level and by what needs to be achieved. but it is a very, very interesting application. The bulk of the data that's used to calculate, let's say, for example, the customer wants to know the clearance, the physical clearance of a conductor, right, live out into the network. And I'll give you the process very briefly on that. You have a device that measures the temperature of the conductor, okay, at selected points along the network, and you have weather data as well. And that determines the temperature of the conductor, and you have the mechanical parameters that are put into your model, and that gives you then a clearance. Now, there's two channels for that information. One is to the SCADA control room, which gives an alarm, for example, if the conductor is sagging too low, right, which is a real safety issue. And then it also goes to an alternative channel, which is the analytics channel, which looks at performance over a number of years, what weather impact will do to the conductors, and all of those other fancier, let's put it that way, applications, right? So it is, and I think it was mentioned in the previous slide there about local knowledge. These things, in terms of the electricity distribution network, are really designed to supplement local knowledge, which is fast disappearing in the electricity distribution world as the engineers get older, like myself, right? And you know, that their local knowledge and needs to be supplemented by having data, if not even real time, near real time. Right, so that's just a little insight into how it works in the electricity distribution and transmission world.
Thank you. And by SAG, you're talking about power line, power cable over a road, for example, that could be high voltage or medium voltage and sagging, and therefore reducing the clearance for traffic.
Correct. It's a safety, sag or clearance is a safety issue. Yeah, and it's caused obviously by temperature of conductor. Right.
Especially in warm climates. Where...
Exactly, and it is dynamic, right? It can be sag with very little load, right? Because it's got high solar radiation and it's got high ambient temperatures, and the conductor can sag very significantly in those situations.
Okay, fantastic. So coming back to deployment now of an IoT solution across a wide area network, a key requirement is to get the sensors in, and obviously have some maintenance program on the sensors in some form. And sometimes you inherit the sensor technology, you know, for a whole bunch of reasons. Can you tell us, maybe Joe, just the practicalities of that and the barrier to entry?
Yeah, I suppose we learned a lot in this phase. I think, you know, it's great, all the technology and the engineers that we have developing the product and the actual, you know, designing it on screen and maybe making a couple of prototypes in the lab. And then you actually have to send somebody out and get up on a ladder, or, you know, hang off of, you know, start getting into the back of a fridge in a store that's operating with other customers running around it. So that became, you know, that was a steep learning curve for us as well. I think that, I mean, it's lovely in the early days of a startup when you are working just in your own zone and you're actually getting the product and you're delighted that you've actually sent data from your sensor up into the cloud and you've recorded the temperature. But yeah, the practicalities, I mean, you have understanding the environments you're going into, and also then understanding, I suppose, the people that are going to be around those sensors day to day as well, especially our ones. We don't really require, I suppose, a maintenance crew. We can do a lot of over-the-air updates unless something completely breaks and falls off and a connection comes up. You know, we work with partners to try and ensure that they can fix them. But yeah, there's a whole business in itself behind figuring out, you know, the deployment once you start getting to scale. And it really does. I mean, even in cost models, and we might get to that later, just in making sure, you know, we know what the price of the sensor is, we know almost how much the connectivity piece is, and the cloud and storage and data. But actually maintaining a sensor, even just one of them, if you've got 50 on a particular site, can cause a lot of issues and costs. So the deployment really has to be thought out, and the pricing model, especially around that, then just has to be thought out as well, because you got to make sure you're covering for those, you know, eventualities. I think it's always going to happen. I mean, well, you kind of said inheriting sensors. We haven't inherited sensors ourselves. But again, yeah, I think that that's going to be an area if people are taking on sensors, you kind of have to do a full analysis of the risk of that as well. You know, how old they are, where they're located, what's the failure on them mechanically, I guess. So no, it's deployment of them. It's all well and good, as I go back to the start, all well and good drawing it out on CAD and drawing it out and designing it on paper and on the screen. But when you actually have to go and have someone that stands on a ladder or pulls machines out, that's when it gets tricky. So it's tough.
And Dennis, what do you do? You're in stadiums and ports and sometimes rail networks that are footprints of 100 miles by 100 miles.
Yeah, so listening to Joe there just reminded me an awful lot of our own kind of situation at the start. So again, we don't rely on maintenance as much because the sensors are over-the-air updates again, much like that. But I think the key point at the start for us was to get to understand the customer's requirements better, because I think what we believe the customer's requirements were against the actual output that the customer needed was very important to us. And that's in different industries as well, Michael, as you say, from stadia to shopping centres to train stations, airports, the needs are different. And I suppose our own assumption of what we thought a customer would want back from those sensors kind of changed over time. So the more and more we evolved into working with these customers, the more and more we realized the level of data that they need back. And because of the data that they want back, we need to look at different sources of getting that data back. Using LoRa, you're using small packets of data that come back, but using other sensors that are there, that are available, gives you a better choice of the data that the customers are looking for. So whether it's using mobile devices for reporting incidents real time back into the dashboard, whether it's just capturing temperature, as Joe would say, of an area that people are working in. So that took us a bit of time really to understand the exact needs. And once we got to that, we understood the questions that needed to be asked in every one of those environments, whether it was a stadia. And now, thankfully, we get the system where we can actually deploy with a plug and play system, so that we can actually ship the packages out to the customers. They can place the sensors in the locations where they need them. And from remotely, we can actually work with those sensors and get the system up and running, which was, from a scale point of view, is critical for us. Because it's the same as Joe was saying, we can't be sending people out to all over the different parts of the world to just deploy a handful of sensors. That we know ourselves, if we get the configuration right, we can get the users on the ground and get the super users trained to be actually able to deploy those sensors for us. So it just speeds up the scale of the environment as well.
And in your case, Mike, you've got often call it technology or product that's in the market for, or in use for 10, 20 years. Sometimes people don't know what's there in these transmission networks around the world. So how do you deal with, you inherit this and you have to improve it. How do you deal with that? Or do you just say, we accept what's there and we'll provide the software and interrogation to actually try and make it better?
Yeah, I think that when you have, Dennis mentioned their over-the-air updates, right? I'm familiar with an installation we worked on recently for a client, which was actually in the Yukon, right? And you know, and I believe that some of these locations are only accessible by helicopter, right? So the opportunity to actually go in there to replace sensors is not an option, right? So we've spent a lot of our time on creating software that provides for virtual, right, operation, right? No, it's not to, and I think that the shift is actually in that way. If I was to look forward, right, that, you know, the shift is away from operational sensors and more into the domain of data science from indirect data. I would say, for example, I mentioned it before, but dynamic line rating. You can actually do dynamic line rating if you know the conductor size, the span, the load that is running through that conductor, which is available in the substation, and the weather data, right? With all of those things, you can enhance, what you know about that conductor, and you can provide, let's say, for example, that you have a number of nodes deployed along that network and you lose a node, which does happen. It's electronics. It does happen, right? So if you lose a node, you can actually create a virtual node by using artificial neural networking techniques, right? So that you've learned what the system is doing, what it has done under certain conditions, and you can apply that. And that's a look to the future, as certainly in the electricity distribution industry, because it is hostile. The domain is hostile. You're in the middle of the Yukon, right? And it's minus 35 or minus 40 degrees centigrade. Not going to be looked at until next summer, right? If you're lucky. Okay, so that's a little different, but it just gives. But the approach is the same, right? And over the air obviously work, right? And you hope it actually works really well, right? But and the need for ongoing diagnostics, right? So that it actually observes everything that's happening within the sensor and gives you a report and gives the customer a report as to the status of that actual node, right? And hopefully you can predict, what its failure will be or whatever, right?
That's interesting. So the common areas in much of what you do is a hostile environment. An environment that you can't get to because it's secured, it's private, and so the access is controlled.
Yeah.
And so to take that for each of you, and Joe, Dennis, how would you, if you were starting this all over again, the startup, roll back, start with Joe maybe, roll back 2, 3, 4 years maybe. You're sitting in bed at night and you have now the wisdom of now, and you roll back. What would you do differently in the whole thing?
I think Dennis mentioned this as well. It's talk to your customers early is the biggest thing. I think we had a lot of ideas, as is when our head is really stuck in the technology and how cool it is and how great we can design this. And we had our ideas that we're going to change everything in this area. But when you talk to a customer, sometimes it's a completely different thing that they're really interested in. And for us, I won't say we wasted time, but I think we focused on probably the wrong things because we didn't speak to enough customers early enough. And I know it might be tough, and I think we felt it's probably tough talking to customers when we don't have anything to show them. And maybe we were new, we weren't new in technology, we weren't new in electronics or building hardware and building software, but we were new in probably the industry we were going into. And we constantly heard, and we could see from the few people that we did speak to, we could see it was a very traditional, very old industry. It was done in a particular way. And we felt by doing anything, we were just going to improve it. And when we showed them this, we were thinking this is a no-brainer. Now, I think a lot of the things we did were probably no-brainers, but every time we spoke to someone, wouldn't it be nice if we could do this instead? And I think what we started out with, temperature monitoring as an initial piece, and we were looking at predictive maintenance. If we can embed the technology inside, we can tell when there's going to be failures, we can tell. And actually, when we started talking to the end customers, the actual people in the store, it really wasn't about the maintenance. They already had retainers and with companies that if something happened, they just come straight in. So we were probably targeting the wrong customer for that. It was actually the energy monetization that they wanted. They knew refrigeration and the freezers were pulling the biggest expense. I mean, it started just with a simple, I think, a drinks cabinet with one of the guys where in a small store, and all he wanted to do at 10 o'clock at night was turn off the Coke fridge, so that he did, because it wasn't required to stay cold during the night, and turn it back on and save the electricity. And then also we spoke to guys wondering, obviously with smart electricity, smart grids coming along as well, can we actually turn on and off and talk when the grid is, and these were, some of them are quite sophisticated, just thinking about this, that, peak electricity times, and when I pay for it, can I actually change the times that I actually drive down the freezer and then turn it off when it hits peak and turn it back on again. So it was really interesting, and it changed our perspective on it. And it definitely changed perspective when we started speaking to the OEMs and the actual manufacturers of the freezers then, that it wasn't just the maintenance, and it wasn't just the temperatures, but what you could tell from it was something completely different, and what we could do with it. And it became, you know, a really, really strong value proposition for the customer. So no, I'd go back to it, that speak to enough customers early and keep talking to them. That's the biggest thing that I would change from our perspective.
And Dennis, yourself and Michael Elliott, if you're rolling back your small number of years and say, what would we do differently when you're sitting in a dark room at night talking to each other?
Yeah. Besides all the arguments we've had about the things we could have done, Michael, I'd say it was similar to what Joe said. I mean, initially, we all thought we knew what was right for the market. We felt that what our solution was going to fix all the issues that are out there in every single industry that we've all had some tie into. But as we reflected and as we started talking to people, and we've done several kind of fact-finding things. We've done surveys with frontline workers to understand their needs. What were they needing out of a software solution, right up to the boardroom. So the needs became completely different, but at the same time they merged. And we found that getting the right platform, getting the right data, where, as I said earlier, and Joe mentioned it, you assume you know the customer's needs. But as you actually go deeper and deeper into it, so it's more, Michael, of doing your research, really, talking to your customers, having a good understanding of their business. And then we'd go back and we'd sit down and we'd trash out what we believe then at that stage is the right solution for both the frontline staff, because these are the ones in our industry that are key. These are the ones that are out there capturing the data. They're the ones that are fixing the issues, reporting the incidents that are out there real time in every single environment. So how we help them was the one key thing that came back to us. How we can deliver data to them quicker, faster. And again, it's going back to a multitude of, whether it's an Android simple basic device, whether it's an iPhone, whether it's a smart device that they're wearing, you know, these things that we found at the time that really came back to us was the needs of the frontline staff. And as we started to grow into that, we realized that the execs and the frontline staff, when you marry both of them together and you looked at the needs, we actually started to build a one-stop shop solution that we were able to get the risks reductions for the actual company by using the data captured by the frontline staff. And when it came back to the execs looking for the data for claims defensibility, as I mentioned earlier, it's down to the ground that the staff were at those locations at the time that we were detecting them using the beacons at those areas that helped drive that performance. So it's research, it's talking to your customers, it's understanding the needs. And I suppose I will say, from an operations point of view, from my side, it's being out there with the guys on the ground initially. And if you can look at the work that they do and then visualize that, digitalize that process, take away all the paper-based systems, digitalize what they do, it just lives the compliance completely. And you'll see that they all absorb the use of software and becomes a very, very happy environment, thankfully.
Thank you. And in your case, Mike, in the issues of how would you, some of these big projects, you go into them and then suddenly discover that the game is not the same. And so if you want to roll back on the last few years and say, okay, if you're doing some of these again, capturing data from different locations and then putting some use to it with a customer that is probably doesn't own all the staff, doesn't own all the environment. So you're dealing with something whereby your customer only own 5 or 10% of the total network, but of people and everything else. But you've got to influence and capture data from a whole bunch of third parties. And
Yeah, I think Dennis hit on it right, very, very well there with regard to the use case. You know, that you need the voice of the customer, but in the electricity distribution industry, there are multiple customers within the customer, right? And you have to disseminate the needs from the wants. Like we're all engineers and we're inclined to, God love us, over engineer things, right? And you need to understand what is the data that is going to bring benefit as to the data that's going to give you a solution that looks really cool on paper, right? And that's always a tendency, right? I'll give you a little anecdote to that, right? Because you know, we were testing, we were doing some original testing on a device with the ESB networks in Ireland, right? And we found a transient had occurred and the network tripped out. And we located where that had occurred, which was wonderful, right? You know, and the local team, as they do with ESB, who are really good, they went to the site and they found a dead crow at the bottom of the pole, right? And so that was the cause of the transient, right? That the crow came in contact with the line, brought it to Earth and tripped the network for a short instantaneous trip and came back again. And I remember discussing it with him. One of the engineers said to me, he said, give us some time and we'll tell you what type of crow it was, right? That's how good. And do you know what it is? In some respects, although that's humorous, right? It's actually a trap in some respects, because it doesn't matter if it was a crow or what it was. What matters where it occurred and how quickly they can get to repair it. That's essential. So if you were to ask me what I would do differently, I'd look at the nature of the data that we actually opted to provide, because you need to aggregate that data into useful bytes, because data, you can throw as much data as you want, but there's a cost to data. There's a payload cost and there's a processing cost and there's a powering cost to actually processing all of this data. So you need to actually focus on what is, first of all, the absolute needs of the customer, right? And then to you know, create the data that will meet those needs and provide them with the solutions. If that was, and I think that that's not just a backward-looking thought; it's a forward-looking thought as well, because you need to actually look at the changes from operational data into indirect data in the same way as the internet have done, right? You know, and they use that data in a data scientific way, right? And I think that that's where it's at the moment, and that's where we're at as a business, is looking forward, I think, to providing lower cost data analytics that are much more valuable, that have a very, very strong value proposition to the customer, right?
Okay, thank you. So coming to the final question, guys, we're going to go into the commercial world a little bit. And so many of these emerging companies in the IoT space, you've got hostile environments, you've got data, you've got telematics of some description, networks, monitoring, large amounts of data. So how do you build a business model around this to scale and make money? And you've got different from your own particular experiences. Give us a flavor. Could be software as a service, platform as a service, and what do you mean by that? Because these are buzzwords. And so, what would your thought process? You've got essentially a bunch of sensors. You've got a load of data being transferred. You've got a software system underlying it. You've got security. You've got a telematics network or a cloud network. You've got data centers. You're either providing a bit of that or you're providing the whole solution for a sector like the marine sector or maritime training, safety centers. So how would you commercialize that? What would your experiential learning be on that for people on this call? So just a quick answer from each of you, and what would you do and what would you not do if there's a not do? So Joe.
I suppose, look, from our own experience, we I suppose we started out wrong, I think, in a sense of monetizing it. Again, it goes back to the customer and where is their primary value ultimately in what they want, and try and figure out, you know, what's that cost to them. And ultimately you can try and it sounds simple, you know, you can ultimately, the solution you provide is going to be, you've got to be less than what the benefit is in, so they can actually see a return on investment themselves and try and calculate that out with them. So, we had a very much software as a service platform to begin with, where, we'll install the sensors and you pay per month to get a certain amount of data, or a certain amount of visibility into the data. But as we get into the energy management side of things, obviously it was the number of devices that scaled up there. So it is very much a hardware-enabled software as a service, as we would call it, where you add the sensors into certain freezers is the primary area that we're in at the minute. But ultimately, the data comes back and how much energy are you saving versus before, and we take a cut of that. So we had to kind of work that, because sometimes cost per sensor doesn't really work to certain industries, and you have to look at the way they want to do business. So I think go back to the use case that and the benefit that you're delivering for the customer, the end customer, try and figure out what that costs them, and how do you make a return on investment for them that's pretty quick. So that's the advice I give.
Yeah, that's interesting. Good. And Dennis, how does it work for Oversea?
That was one of the most difficult questions, Michael, at the start. How do you monetize your business? And we looked at loads of different cost models. We went at by location-based costing, by company-based costing, as in you roll it out as an enterprise solution. And again, it's no more different what Joe said. You try different things at the start. You need to look at what's best for your customers. Different customers have different requirements. And as we've evolved as a SaaS, software as a service, we've kind of narrowed it down that different industries have different use cases. So some industries are happy to take it user-based. So they'll buy a license based on the users that they have in their shopping center or their train station. And then you get users that are primarily rolling out devices and IoT sensors and capturing that data and bringing that back. And exactly what kind of Joe mentioned there, it's going by device, and it's just kind of building that platform for them. And one thing we learned was, as the years have progressed, sensors are getting cheaper. They're getting better sensors out there to get the data. And I suppose once we started building the ecosystem for that and bringing that data back, we found it an awful lot easier to monetize that and to actually explain that to our customers, which was the hardest part. The initial point, Michael, was getting customers to understand that you could have a mix of the two worlds. You could have a mix of the user-based system for what you use on the ground with your users, and then using your IoT sensors and allowing them to scale as the sensors grow and as more and more sensors become available, to allow them to add those into their network and into their system.
Okay, fantastic. And finally, Mike, how do you monetize? And what is the ideas you've got? Especially you're more in the data world than in the sensor world, but
yeah, it is a difficult question, right? As Dennis and Joe observed there. And I think that there's a fundamental here that the industry that we're involved in, which is electricity distribution and transmission, is economic critical. I mean, it is a very, very difficult industry to actually break into, because I mean, they don't, right now, I would say that there's very little scope yet for any sort of cloud-based approach to even monitoring, let alone control, using distributed devices. So what each one of these is a separate project in its own right. Each customer is slightly different, and there is a requirement in most cases to actually partner with an established utility provider. In that case, it could be, and there's probably only 6 or 7 of those globally, the likes of ABB or Siemens or General Electric, right? And that is to become part of that offering. That's where we're at the moment. I can see that changing as the adoption of cloud-based solutions becomes more prevalent. But it's right now at the moment, it's really very much, you point the data into our firewall, through our firewall into our server. We'll give you limited access to that, and we'll utilize it then as we require. The industry is probably 30 or 40 years behind, right? And I come from an electricity utility background, right? So, that's the reality. And you can actually understand that too. They're very, very risk averse.
Mm-hmm. Yeah. That's very powerful, because one of the opportunities is that there are many industries that are very, very good and mission critical who are many years behind.
Yeah.
And so that's a real opportunity for developers of IoT devices and IoT networks. And that's on that point, I think it's a very good point to end. And I'd sincerely like to thank Dennis, Joe, and Mike for the frank insights and the openness that you've given us today. And to our audience, if there are any questions, we don't have any at the moment, but that's okay. If you want to poll something to Maria, we can try and deal with it at a later time. So back to Maria and your discussions and presentations from the Halpin Centre and from the Nimbus Centre in Cork on behalf of the Munster Technological University. Thank you, Maria.
Thank you, Michael.
Take care.
Thank you.